If you've ever used a map on your cell phone to get you from place A to place B, you're familiar with the idea that a map is simply a representation of some sort of area that actually exists in the real world. So a map on your cell phone is a digital map of an actual place somewhere in the world. Similar to this digital roadmap, your brain also has a map of your body, and this map is something known as the somatosensory homunculus. The somatosensory homunculus is basically a map of your body in your brain. And let me go into this because it is a little bit confusing conceptually at first. So what I've drawn over here is a picture of the brain. Let's just focus in on this pink area over here. This pink area is something known as the cortex, and this region that I shaded in orange over here is a specialized part of your brain that receives sensory input from your entire body. So whenever you feel pain or whenever you feel some sort of heat anywhere in your body, all this information is actually sent through the spinal cord into the brain, and it all ends up over here in this one part of the cortex. And this part of the cortex is known as the sensory strip. So let me just clean this up a little bit. So if we were to actually take a cross-sectional look at the sensory strip, so if we cut the brain just right down the middle and kind of looked at it this way, what we would see would be this large orange structure that I drew here. So this orange structure is basically just the sensory strip, and we're looking at it this way if we cut it right down the middle. And so as I mentioned before, this sensory strip contains a somatosensory homunculus. And the somatosensory homunculus is basically a map of the body in the brain. And what I mean by this is that information that comes from your hand to the brain will all end up in one part of the sensory strip. So information from your finger will actually come over here. Information from these fingers will come over here. Information from the palm of your hand will come over here. Information from your wrist will actually end up over here in the sensory strip. And similarly, if we were getting information from your foot, the information from your foot would all synapse over here in this part of the cortex, and information from your toes would synapse over here. So you get the idea. Basically, information from various parts of the body will come into the brain, hit the sensory strip, and it'll always go to one part of that sensory strip. So this is your face over here. So this would be the face. And so information from the lips would come right here. Information from the eyes would go over here, and so on. So basically, the sensory strip always receives information from different parts of the body, and that information will always go to one part of the sensory strip. So let me again clean this up a little. If this is still a little confusing, let me try explaining it a different way. So let's imagine that there was a brain tumor right over here. This brain tumor would kind of look like this. It would basically be in this region of the brain. And so in order to figure out what part of the brain is tumor and what part of the brain is normal, neurosurgeons can actually go in with an electrode and touch different parts of the cortex. So they can actually come in and touch this part of the cortex and touch this part of the cortex. And this electrode will actually cause the cells that it touches to stimulate. And so in some cases, the surgery can actually be conducted on patients that are awake. And so if a surgeon touches this part of the cortex, patients can actually say, oh, I feel as if somebody is touching my wrist. And if the surgeon touches this part of the cortex, people might say, oh, I feel somebody touching my forehead or my eye. So depending on what part of the cortex the surgeon places his electrode, the patient will get a sensation of some part of his or her body being touched. The reason that surgeons do this is to make sure that they aren't removing parts of the cortex that are involved in sensation, because if the surgeon were to remove this part of the cortex, the patient would no longer have any feeling in the wrist or in the forearm. So they need to make sure that the part of the cortex that they're removing is not involved in sensation. Otherwise, the patient would actually lose sensation. Similarly, if the surgeon removed this part of the cortex, the patient would lose sensation in the lips because this part of the cortex actually receives input from the lips. So let me again clean this up just to go over everything one last time. So the sensory homunculus basically maps out the body in the brain. So as information comes to the brain from different parts of the body, information from the hand will all synapse in this region of the cortex, information from the face will synapse in this region, information from the feet will synapse in this region. And so what this effectively creates is a topological map of the entire body in this strip of cortex. And this topological representation of the body in the cortex is what's known as the somatosensory homunculus.